In lesson 5.1, we talked about solving systems by graphing, and in 5.2, we are going to learn about substitution, which is one of the more common ways that we solve systems if we're not graphing. A couple things before we start. What does it mean to substitute? We often use this term plug in, like if I know the value of x and I have an equation, we say, well, just plug it into the equation. So what we're doing is we're replacing an expression or a variable with something equivalent. So when I know what x is, I can plug it in for x into an equation. Got the steps that we may go through over here, which won't make as much sense right now, but we'll go through those steps as we're solving. So let's just jump into number one and then see how we may use these steps. Okay, so step one says solve either equation, meaning get this as like x equals something or y equals something. You don't always have to do this. So if we look at example one, I already have one of my equations solved. So this is one of those cases where I don't have to do this. It's already done for us. Step two, substitute into the other equation. So usually in the past, when you've substituted, you have like x equals 5 or y equals some number, and we're just plugging that in. And now we're going to do it with an entire, or with this, I guess, two expressions together. And since y equals all of this, I'm going to substitute all of that in for y. So here's step two. I've got 6x minus 5 times y. But since I know y is negative 2x minus 9, I'm just going to substitute that in there. And then everything else stays exactly the same. So notice what we did. I took this other equation, and since I know y is all of this, negative 2x minus 9, I substituted that in for y. So now this is a little bit ugly, and we need to do some simplifying before we can really start doing much solving. So I've got this negative 5 out here that I'm going to distribute. So let's just start rewriting here. I've got 6x, negative 5 times negative 2x is going to give me positive 10x, so plus 10x. And then negative 5 times negative 5 is plus 45 equals negative 19. Next step, we can combine some like terms. So this is where we're now, this is really part of the solving part, right? We're really in this step right here. I guess, well, it depends on the way that you look at it. We're really just simplifying right now. We're not doing much solving. Let me get to another step, and then we'll call it officially step 3. So 6x and 10x, I can combine those into 16x plus 45 equals negative 19. Now we're really to the point where we're going to start solving. We're going to do things to both sides of the equation, and that's what I really consider the solving portion here. So subtract 45, and we end up with 16x equals negative 64. And then to get x by itself, I'm going to divide by 16. And we find that x equals negative 4. Now, step 4, now that I've found x, I can plug this x back into either of these two equations in order to find my value of y. Oftentimes, one is going to be much easier than the other. So in this case, that top one looks a lot easier to me because I've already got y equals something. So step 4, y equals negative 2 times x, which now I know is negative 4, minus 9. And we just simplify. Negative 2 times negative 4 is positive 8, minus 9, y equals negative 1. This is a process that it takes a little time to figure out. If you need to rewind and watch that again, I would recommend doing that just to get a feel for this process. Example 2. This is going to be just slightly different. Again, step 1 says, well, let's solve either equation. Not always necessary. Here's the other thing that you need to look out for. 3x here, 3x here. Since I know 3x equals all this stuff, again, I can just substitute it. They match, right? This is an expression. Since 3x is y plus 8, I can substitute in y plus 8. So this bottom equation then becomes y plus 8 plus 2y equals negative 1. So this is something you need to be on the lookout for when you're doing these problems. Do I have something that matches? If not, that's when you're just going to want to solve for a variable. So again, we got to combine like terms. I've got a 2y and a 1y, so that becomes 3y plus 8 plus negative 1. Subtract 8 from both sides. You get 3y equals negative 9. Divide by 3, and y equals negative 3. Final step then, I'm going to plug this back into either equation. As I'm looking at these again, I've got x all by itself. It's a 3x, but I think this one's going to be a little bit easier. You'll get the same answer no matter which one you plug it into. So I'm going to plug that back into the first one. So 3x equals negative 3 plus 8. 3x equals 5. If I just combine those like terms, divide by 3, x equals 5/3, which is approximately, well, it's exactly 1.6 repeating, approximately 1.7. Final example, if you're watching this for the first time and going through, I would try this one on your own. It's pretty much exactly like the one right up above it. You just end up with numbers that aren't quite as nice. You end up with some decimal numbers, which is fine. But I would try that and then come back and watch. So again, we've got that same situation as above, where I've got 5x equals something. And up here, I've got another 5x. So let's substitute this in for 5x. So I've got y plus 5 plus 3y equals 11. Combine like terms. 4y plus 5 equals 11. Solve for my variable. Divide by 4. And we get y equals 6/4, which works out nicely as a decimal to 1.5. And again, we're just going to substitute it back in. You can do this either way. To me, this equation looks a little bit more simple. So when I now substitute in for y, 5x equals 1.5 plus 5. See what I mean about the numbers just not being as nice, but it works out just fine. I can combine those like terms. 5x equals 6.5. Divide both sides by 5. And x equals 1.3. Final problem. We have another story problem. We've seen a couple of these in this section. We are just going to use technology to graph this and find the solution. You certainly could use substitution. It actually works out pretty nicely as long as you choose the right equation. But it's not pretty. So we're going to save ourselves a little work here, focus on the setup, and then solve with technology. Club earns $1,088 on opening night and $1,183 from a second performance. On opening night, the club sells 68 adult tickets on 136 students. For the second performance, 79 adult and 140 students. Write the equations, determine the price of each ticket. Again, I would try to set this up on your own and then come back and check your work. So what we're looking for is the price of each ticket. So we've got adult tickets and student tickets. I'm going to let X be my adult ticket price and Y be my student ticket price. So if we look at the opening night, we've got, this is our total amount earned, 68 adult tickets, 136 student. So remember, to find price, if I take how many I sold times the price of an adult ticket, that'll give me the amount of money made from adult tickets. So I've got 68x, and I have to add to that these student tickets. I sold 136, and that's the price of that ticket is represented by Y equals 1088. Set up a similar equation for day 2. So we've got 79 adult now plus 140 student, and our profit was 1183. So we're just gonna punch this into Desmos and find our solution by looking at the intersection like we did in the previous section. So I've got this already set up to go here. My equations are plugged in here on the left, and if I find the intersection, I've got x is 7 and y is 4.5. So our solution to the system is 7, 4.5, meaning that the adult ticket price is $7 and the student ticket price is $4.50.